A student carries out a titration to find the concentration of some sulfuric acid. The student finds that 25 centimeters cubed of 0.088 moles per decimeter cubed sodium hydroxide is neutralized by 17.6 centimeters cubed of dilute sulfuric acid. There's your equation for this calculation. A bit more to the question here. After carrying out the titration, the student left the resulting solution to crystallize. White crystals were formed with a formula of Na2SO4.xH2O and a molar mass of 322.1 grams. So quite a lengthy question, lots of information to try and digest there. And before we even look at what we have to calculate, you can start to see here why students will start to panic. All right, you've got lots of information, lots of numbers floating around. What you've got to do is stop, take a moment, organize your thoughts and think about what numbers refer to what chemicals. Okay, so two things to do here. We're going to work out the concentration of the sulfuric acid, and then we're going to work out what X is. So it's going to be two slightly separate bits, this calculation. So let's start off with the concentration of sulfuric acid. So we go back to the beginning of the question and let's see what we've got. The idea with any question like this is to try and work out moles of something. All right, that will almost always be your starting point, and that should hopefully then lead you on to other discoveries when you've realised what you've got to do. So the student carries out the titration. The student finds that 25 centimeters cubed, there's a volume of 0.088, there's a concentration, sodium hydroxide. So I've got information there I need to calculate a number of moles for my sodium hydroxide. I've got a volume here, my titer value for the sulfuric acid. The ratio from sodium hydroxide to sulfuric acid will therefore tell me how many moles of this I've got, and from there I can work out its concentration quite easily. So let's start here with my number of moles of NaOH. It's concentration times by volume divided by 1,000. Apologies for the reflection of the lights there. Let me just move it up a little bit. So concentration is 0.088 times by the volume, 25. Divide that by 1,000. Gives me then a number of moles of sodium hydroxide of 0.0022. Okay. Looking now at my ratio, I can see that 2 moles of sodium hydroxide will react with 1 mole of sulfuric acid. So to work out my moles of sulfuric acid, all I need to do is use that ratio. So the moles of H2SO4 is going to be half the value of the moles of sodium hydroxide, because for every 1 mole of sulfuric oxide, it requires 2 moles of sodium hydroxide to react. I've worked out I've got 0.0022 moles of sodium hydroxide, so I'll need half the amount of sulfuric acid to react. So 0.0022 divided by 2 is obviously 0.0011. So this is my moles of sulfuric acid. I've got the volume here, so I can now work out its concentration by rearranging this formula. So if moles is C times V over 1,000, concentration will be the number of moles times by 1,000 over volume. Put the numbers in. 0.011 number of moles of sulfuric acid times by 1,000 divided by the volume of sulfuric acid, which is this number here, your titer value, 17.6, and that will give me then a concentration of 0.0625 moles per decimeter cubed. There we go. So that's the calculation to solve the first part of this question. If I just move the question sheet up a little bit again, you can see the second part there is to work out the value of X in the hydrated salt. Okay, you've been given the molar mass of the hydrated salt here. So this is just a case then, a simple subtraction. If we know that all of this has got the molar mass of 322.1 grams, I haven't got to use anything here. This is just this is a completely separate calculation. All I need to do is figure out the molar mass of just the anhydrous salt, just the Na2SO4, and subtract that away from 322.1. That will give me XH2O. That will give me the sum of all of the water molecules present. Finally, to get X then, I know that water has got a molar mass of 18 by looking at the periodic table, 16 for oxygen, 2 1s for hydrogen. I will then divide my number for XH2O by 18 to give me X. So let me show you through this one. Let's move this up a little bit. So we know that the molar mass of the hydrated salt of Na2SO4.xH2O is 322.1. That's given to us in the question. So if I work out the molar mass of just Na2SO4, so there's 22 lots of 23 for the sodium, 32.1 for the oxygen, and 4 lots of 16 for the, 32.1 for the sulfur, 4 lots of 16 for the oxygen. Add them all together, that gives me a molar mass of 142.1. So if I now subtract that value from the total molar mass, that leaves me with just XH2O. The MR of just XH2O is a difference, which is 180. So therefore, X, if I now take the MR of water, which we know is 18, if I divide that by 18, will give me X as 10.